Alright, what's up guys? I'm going to show you guys how to solve this problem. It's pretty easy, but confusing at first. So right here is the equation you're going to want to pay attention to. So we have A, where we start that, we have A times E is a constant to the power of R times T, and that's going to equal Y. So we have two parts, two different equations. We have right here you see a single bacterium and then 10 bacteria. So a single bacteria, so we're going to start with 1 because that's our single bacteria, 1, and then E is a constant, and our rate's going to be this. So this is our rate. So to get that as like a decimal kind of rate, we're just going to do 160 divided by 100 equals 1.6. So this is just like our rate's going to be 1.6. If your growth rate was 280, then your R would equal 2.8. That's pretty easy though. So R is 1.6, and then T is time. It tells us that a single bacterium infects a person. The critical level is reached in 24 hours. So our time is 24. So we're gonna get this equation. It's set equal to Y, but we're gonna get this equation. We're gonna plug it in to solve for Y. So we go up here in Desmos. I plug that same equation in, and I get this really long number. I'm gonna use a full precision calculator. I plugged it in, and now I have like the very full number, just to save me a little bit of time. So I'm not typing all the zeros. I get that very long number, and let's just say that really long number is let's just say it's X for right now. We have to do the second part of the equation first. So the second part is how long will it take 10 bacteria to get that level, right? So we're gonna start with 10. Because that's 10. E is a constant, and then our rate's still 1.6, except it's with 10 this time. And we don't know how long it's going to take to hit that critical period. So we're just going to put in T. And then we're going to set this equal to this equation, which came out to be X. So this is pretty much just going to be equal to X, or that really long number. So let me show you what I mean by that. We're going to go over here. We have this really long number that we solved for earlier. You put in the precision calculator. We're going to set this really long number equal to that 10e to 1.6 to the x. This is like this. So this right here is the exact same thing as this. Instead of t, it's x, and this doesn't even matter. So you plug this in. If you zoom out, or if we turn it on, sorry, the line it wasn't even showing. You can see that this is set. This equation, it shows up one line, and because it's one straight line, it means it's one x value. I'm gonna go here real quick. You can kind of see that it's like what 20, like it's like by 22.5. So I'm just gonna real quick go change just the graph a little bit to look a little easier. I'll do 22.5 to 22.7. So just so it zoomed in, you can kind of see that we're zoomed in real close to 22.56. So your answer's going to be 22.56. Let me type that in blue just so you can kind of see it. 22.56 is going to be your answer for this equation, and that should be in hours. So for the critical, the amount of time it takes for the 10 bacteria to reach a critical level at this rate, mine's 160, is going to take you 22.56 hours. I hope that helped. Thanks. Yeah.